Hello everybody! Welcome to our video solutions to quiz 3. This is the fall 2021 what are we in, fall semester? Yeah, fall semester 2021. This is Math 106, which is integral calculus and differential equations. And this quiz is all about improper integrals, right? Which is our prelude to Laplace transforms, which is going to be our super duper methods for solving differential equations. So what makes these improper integrals? Well, in all these you'll notice we have these infinities, right, in the bounds of integration. So we're talking completely right now about improper integrals with what I call infinite limits of integration. There's another type of improper integral where your function is discontinuous on the interval of integration, but we're not going to be talking about that in this video. So let's start it out here. Let's try this A. So in A, we're integrating from 0 to infinity, e to the 4t dt. All right. So I'm going to give a name to this function. I'm going to call it f prime of t. You say, well, why f prime? Well, I want to use the fundamental theorem of calculus. And when I use that, I want to view the integrand as the derivative, right, of some function. And then I'm going to take its antiderivative. So let's just copy this over here. Right, so an antiderivative of e to the 4t is a fourth e to the 4t. Right, if I take the derivative of an exponential, it's basically going to be the same, except I have to multiply by the derivative of the exponent because, chain rule. So that would here give me a derivative of 4t, which is 4, and that's why I needed this 1/4 to compensate. Okay, so my improper integral then is going to be f of infinity minus f of 0. Now, you might get really angry. You say, well, f of infinity, you're not allowed to do that. You can't put infinity into the function. And of course, you're right, but we made this definition. F of infinity is the limit as t goes to infinity of f of t. Okay, so this is just a shorthand for what we really want to say. All right, so what is happening as t goes to infinity in our function, right? Well, okay, this 1/4, that's not doing a whole lot, but now we have this exponential. And this is not exponential decay. This is exponential growth. As t goes to infinity, this exponent goes to infinity, this exponential goes to infinity. Ooh, we divided by 4. Yeah, still going to infinity. So this is going to go to infinity. What about f of 0? Well, it's not going to matter a whole lot, because f of 0, let's see, e to the 0 is 1, so times a fourth. So this is actually equal to 1/4. Okay, you got infinity, you got rid of a fourth. Yeah, that's still infinity. All right, so this improper integral diverges, and we could even say to infinity. All right, sometimes they don't go to anywhere, but it's kind of maybe a special case when it diverges to infinity. Now, we could have just guessed that right at the beginning because you have an exponential function. It's growing really, really fast. Yeah, and this integral is just computing, right, the accumulation of the function, and that's just getting more and more as you go. So yeah, this should diverge to infinity. All right, let's try B. So B, we're integrating from negative infinity to 1 over t cubed. Okay, of course, this should be a -1, right? That's the -1. Okay, how do I know this should be a -1 and not a 1? Well, you see, when you go from negative infinity to 1, forget about the minus, you have to cross through 0. And this function is not even going to be defined at 0. Okay, and we're not talking about those type of improper integrals here. Okay, so we definitely want, right, a minus in front of this 1. Okay, fine. So again, I'm going to define here this to be g prime of t. So g prime of t is 1 over t cubed, and I need to find an antiderivative. I don't like writing it this way. I'll write it as t to the -3. That means I can use my power rule. Okay, so let's see. I add 1 to the exponent. That gives me -2. And then I divide by the new exponent, so -1/2. Okay, so my improper integral is going to be g of -1 minus g of -infinity. And okay, we can do g of -1. We'll feel annoyed by this, right? We'll work that out in a second. Okay, so what happens at -1? if I put in a 1 for t, or a -1 for t, well, let's rewrite this. Maybe it's easier to write it like this, 1 over 2t squared. If I put in a -1, oh good, it's going to get squared. So it just becomes a +1 times 2, and then we have -1 over 2. So this is -1/2 minus, okay, so what is this g of -infinity? Well, again, this is our definition, the limit as t goes to -infinity of g of t. Okay, so what's happening as t goes to -infinity? Well, doesn't matter actually if it's going to -infinity or +infinity. You're squaring it. So it's just getting huge. We know that. It's going to infinity on the bottom. Times 2, still going to infinity. But when you do 1 over something going to infinity, you get something which is going to 0. Put a negative, still going to 0. Okay, so we could just write 0 here. And so in total, we're getting -1/2 as the accumulation. Does this make sense based on maybe a graph? So 1 over t cubed, well, if we graph the right-hand side, maybe it's looking something like this. All right, so there's 1 over t cubed on the right. What does it look like on the left? Well, it's just the same thing but negated, because 1 over t cubed is an odd function. Okay, so what we're asking for is between 1, or -1 rather, and -infinity, what are we getting? Okay, well, first thing you notice, it should be a negative value, right? Now, in terms of the size here, well, maybe it's not so obvious how much negative, but it definitely should be negative, right? And it is going to get small really quickly. So maybe this isn't an outrageous guess for the actual answer. Okay, let's move on to the final integral. So this one, oh my goodness, it has an infinity on both the top and the bottom. Now, here's where we need to be very, very careful. All right? When we defined an integral of this type of improper integral, we did not say you could just find an antiderivative and evaluate it at the endpoints, right? You have to break this up into 2 separate integrals. That is our definition for an improper integral with infinite upper and lower bounds. So the first thing I'm going to do is just pick some number, any number I want. I'm going to choose 0 because it's kind of the easiest, right? But I could choose anything I like in between. And so I'm going to break this up as an integral from -infinity to 0 plus an integral from 0 to infinity. If you do not break it up, it is wrong. Right? You might coincidentally get the correct answer, but you might not. Right? We have examples where if you don't break it up, it might look like this integral actually exists, maybe it's even equal to 0 or something, but in fact, it doesn't by our very definition of this. So we have to break this up. All right, now in both of these, the integrand is the same, so I'll only have to do that work once. So let's see here. We can make this a little bit smaller. Get that out of the way. Very good. Okay, so here we go. Our h prime of t is e to the -t, and h of t, well, we need an antiderivative for e to the -t. That'll be -e to the -t. Okay. Of course, the same thing is going to hold, right? Over here, it's the exact same h, or h prime. All right, so this first one is going to be h of 0 minus h of -infinity. Okay, that's the first piece. The second one is going to be h of infinity minus h of 0. All right, let's compare what's going on. So in the first one, we have h of 0, which is going to be -e to the 0. So that's -1. Okay, minus, okay, now we need to know what happens as t goes to -infinity. As t goes to -infinity, what happens to this -t? It goes to +infinity, which means this thing is blowing up. Well, actually, with a negative, it's blowing down. So this actually ends up going to -infinity. Okay, and I'm going to finish this off, but it doesn't actually matter. This bit right here is going to infinity. When we integrate this exponential from negative infinity to 0, it's actually by itself diverging. So then the whole thing cannot. All right, but we can check out the rest of this just for fun. As t goes to positive infinity, well, this is a decaying exponential, so it goes to 0. And then at 0, well, again, we get negative e to the 0, which is going to be negative 1. All right, but in total, this thing is going to infinity. So this diverges again to infinity. Okay, so the right-hand side, right, this one where we go from 0 to infinity, that would actually have converged, right, to positive 1. But the left-hand side does not. And this is, again, if we draw the picture, okay, exponentials go like this. Decaying exponential looks like this. Okay, so this is e to the negative t. On the right-hand side, this actually does get small fast enough that you'll get a convergent accumulation. But on the left-hand side, oh my, look at how much accumulation you get, right? And it just gets even more. So it's not a big surprise, right, that this whole thing should go off to infinity. All right, we'll see you in the next video.